Good morning, friends. I'm going to talk in a meta way. You could call it teacher to teacher about the slideshow, which I'm encouraging anyone to use. It's Lightning Talk compatible. Says that in the note below. Pythonica, I think that's pretty cool. Now, I want to say something up front about AI generated images. In my line, in my subculture, you just throw these out without any you're not trying to hide the fact that this is AI generated. It's taken for granted. It's obvious. The practiced eye can see that it's AI, especially when you're not even trying to hide it in any way. You're just throwing these things into slideshows because it's very useful and convenient. It's another tool. And anyway, look, these two snakes, or is it four snakes? There's some coolness here. There's some puns, like we're alluding to the Python logo itself, you could say, because that has that sort of face card look. You know, the royals in a deck of cards, queen, king, jack. Those typically have this sort of symmetry, which the Python logo alludes to. You could think. I always think, playing cards are the paradigm thing you use when you're introducing probability and the whole science of statistics, and Python did get into that world very nicely, maybe because the playing cards significance, the joker value, but also it's a good language. Anyway, let's move on. I'll just say what we're bringing up here actually in this whole slideshow, it's only 7 slides, kind of with the commercial at the end. So really more like 6 slides. We're trying to show, okay, what you want to set your audience up to expect in under 5 minutes. I'm taking more than 5 minutes because this is not a lightning talk, but a lightning talk is never more than 5 minutes in the Python subculture, and this is one of those talks where you're saying, look, every computer language comes with a meta language, which includes mental imagery, analogies, metaphors, and it's not like these are all universal to all languages. It's when you go from one language to another, you need to sometimes break a mental picture that worked really well for the previous language. It's not like these metaphors are proved ultimately true or false. They are more or less useful as you go from language to language. And what we all learn, or if you went through the same curriculum I went to, even remotely similar, you're going to have encountered a lot of texts which drill into you that a variable in a computer language, x equals 3, for example, oh, that's like putting the number 3 in a box labeled x. So a variable is like a box with a name on it. And inside the box is the value, what the variable holds or contains. And in Python, that's going to get you in trouble, that image, somewhat. And the user is going to look at this picture and think, wait, how was that 4 snakes? 2-headed snakes? Are those two-headed snakes? This looks like the number 88 and blah, blah. Okay, reverie time. It's geeks, right? They're looking at their own laptops. They're probably doing email. They're not paying much attention. That's cool. So here's the better analogy in the metaphor world. Many kids holding the same balloon came out good in AI. The prompt was pretty clear, and at least 2 out of 3, 2 out of 4 were good on that score. And the luggage tag came out great too. Now you can do your own prompts. If you don't want to do this exact slideshow, I'm encouraging a lot of us to just use these slides because I'm trying to institute this subculture where people do all share the same slides, kind of like we all share the same textbook. It's not like there's just one textbook or just one slideshow. And what you might want to do, this just came to me recently, is use this slideshow as part of a longer talk, not a lightning talk, where you use slideshows from 5 or 6 people, all of whom are feeding the same pool of open source slideshows or freely shareable slideshows. I'm not saying don't give me any credit or anything. My name's on the first slide. Like these slides, if you present them, you don't have to say you created the slideshow, but everything you say, that's not pre-scripted. I give you my version of it from time to time. I go through my slides. This one in particular, though, it's so, I've got some verbiage for you. There's that don't read your slides advice, which I don't actually think is great advice. I think sometimes you do want to read your slides. But what I'm saying between the two of these is that the better way to think of a name in Python, like X or Y, is there like a string attaches the name to the object. And the object can be big and heavy in memory. It can literally be like an engine on a switching yard in a train station or switching yard, right? You're up there in some tower and somehow you're writing little Python like train.start and a real train out there starts moving because of what you just did. So that's the way to think, memory objects can be big and heavy and you don't want to copy them gratuitously. The economy model here, the Python model, is be economical with copying and duplicating. So if I've assigned the name X to the suitcase that's like a list of prime numbers, say the first 100 prime numbers in a list, and I say X equals that, first of all, equals, we can call it the equal sign, but it's really the assignment operator for us. And it really is the act of the slapping of a luggage tag on a suitcase, you could say, or attaching another string to the balloon. And there's a lot you can go off into the whole thing of garbage collection and reference counting, all that. You can do that. So then, instead of just a string or luggage tag, think of it as a TV remote. And this is a great doorway into the whole dunder thing. Double underline, special names, because you have a preset, like your remote has preset buttons. Python has preset buttons. The ones that you push to activate these preset magic names, sometimes called, or magic methods. The double underline scaffolding that comes with Python that is so signature to that language. The TV remote is like the buttons that you need to endow your objects with if you want syntax itself to be controlled by that type. Like, what does square brackets mean, or what does calling it mean? You've got control over that with dunder get item, with dunder call and stuff like that. So that whole slide with the TV remote could be your jumping point to other slide decks. So then I'm going back and saying, look, there's nothing wrong with saying that a variable is like a box and the values of the variable is like whatever's in the box, and the box has a name and blah blah. And in some languages, if you say X equals this box or X is this box, and then you go Y equals X, you get a copy. Y is now just like what X has. They both have a snake in it. Two-headed whatever. But now each one can be changed separately because there's copies, right? What you do unto one, you're not doing unto the other because they're separate in memory, the two snakes now. You did Y equals snake, and then you did X equals Y. So X and Y are two snakes now, right? Well, if that's so, then hey, your box analogy is working. But that's not how Python works. When you do Y equals snake, and then X equals Y, well, now X is just another luggage tag on the snake or on the suitcase, another string on the balloon. You haven't made a copy. The train in the switching yard is still just the one train. But now 5 people have TV remotes. They can all mess with the train. I'm not saying that's good design. I'm not saying you should have a lot of names for the same object floating around in your code, but you can. It's part of the syntax. Like, why did you need synonyms anyway? Maybe you wanted a copy. Well, that's the thing. You often do. When you assign a second name, sometimes you just intuitively, because of your background, you're thinking, oh, I'm going to get a separate copy. And then you're surprised by this behavior. This is my last sort of working slide, you could say. I create the triangular numbers. Now, if you've not read Python, that formula there in the beginning, n times n plus 1 over 2, the double slash 2 means integer division, meaning we know this can be turned into an integer. It's always an even number. And if you think about it, if n is odd, n plus 1 is even. Even times odd is even. And vice versa, if n is even, then n plus 1 is odd. We're still even times odd, so still even. So you can always divide by 2 with no remainder. So the result of that computation is just an integer. And then, okay, so for n in range 1 to 12, so how that works is n gets to be the name of 1, of 2, of 3, of 4, all the way up to n is 11. Now 12 is like the limit you don't ever reach. So its stopping point is just where you can't go. So you get up to 11, then 12 is like, nope, can't go to 12. If you want to go to 12, you should have said 13. So that kind of thing. And so what comes out of this is just a list of triangular numbers. You can visualize them as, pool balls or some kind of billiard balls, First you just have one of them, then you have 3 in a triangle, then you have 6 because you added a layer, then you have 10 because you added another layer. Always one more ball in each layer, and so you go on out triangular numbers, and then you assign other name to try numbers. This is the kicker, because the equals sign assignment operator didn't just make a copy at that point, and you can check that by using the word is. It's a key word in the Python language, and you get true, which is to say that other name and try numbers are both tags on the same suitcase. They're actually names of the very same object in memory, same train in the train yard. And then I prove that by changing element 3, 0, 1, 2, 3 to none, print out other name, or not reprint out, but print out other name, or have it represent itself more strictly. Just by typing other underline name, I trigger the underlying dunder repr method, which causes it to represent itself as you see 1, 3, 6, none, 15, 21, blah, blah, because up above I changed try numbers. And you're like, wait, you changed try numbers. Why is other name different? Oh, well, that's what I'm saying. There's the gotcha. That's what you need to get. Is that to change one is to change the other because there's only one object. You open the suitcase, you take something out, it's like every name of that suitcase has been affected by that. Even if your remote's different from my remote, if I turn the TV off, the TV's off now. So if you plan to do anything with your buttons, you're going to have to turn it back on, that kind of thing. Again, I'm not saying we always want to have competing TV remote pattern. That is a pattern, but all I'm saying is that the same object can have many names in Python. And down below, I show how to start over, create try numbers again as those triangular numbers, and this time use the .copy method on try numbers. Try numbers, the list, being a list, knows how to copy itself. .copy will do that, and you get other name now has its own copy. And here you could jump to a whole other slide show about shallow and deep copy. Like, did you really mean to copy the whole thing? Or, there's some compromises here. And again, Python tends to economize. So you have to work, you have to ask for a deep copy, blah, blah, So there's more to all of this, obviously. But that was just 6 slides. And then the 7th slide is the Mandelbrot. It should jump out at you. That's the paradigm fractal guy, and it's just ASCII art though. And the code behind this, which we don't go into, just generates this ASCII, and it's not very much code. And if you want to switch to NumPy, okay, even less code. And this is all part of a whole curriculum where I have these things called tractors that are kind of rastering across the field. We're looking down, drone, looking at the farm, and there's like these riding tractors, and there's a subclass, the crop circle tractor, that actually creates these Mandelbrats. That's me previewing an entire other presentation. If you liked this one and you want to know more about tractors, tractor graphics, I call it, ASCII art output and stuff, then go to Unicode. Learn a lot of computer science here, not just Python. Then I'm showing the teaching tips link here that you can go to, and then I'll say a few words. This channel doesn't have a lot of like pure Python, you could say. And a lot of the Python is kind of seems very kid oriented. If you were to scroll back in the history of this channel, there are hundreds of videos. And there's a lot of Python related content, but it's not like what you'd call pure Python in that there's strong context either. It seems to be for kids. Like I use Codesters a lot, which is an in-browser sort of dialect of Python that is inspired by MIT Scratch. So it lets you move to Python syntax and yet have kind of Scratch-like moving animated sprite output. I do that a lot, and then I also merge that in with this whole Martian math thing, which is in 2025 still only like elite school kind of stuff. Like if you go into your average public high school in the US, you will not be getting what most of my videos are about here in 2025 yet. But I'm an international school kind of product, expat, and so on. And I think at that level, schools try to differentiate. It's like, oh, our curriculum's a little more edgy, a little different, more contemporary. We've got more of blah, blah. And I fill in those blanks a lot, the blah, blah part on this channel. So just a forewarning, that is probably not your best place to get just straight Python, if that's what you're into. But this particular video kind of is straight Python. Okay, man. Talk to you next.